In this video, we're going to talk about the path that a lot of engineers take to go from a problem to a solution. This is not the only design process that you can use. It may not even be the best design process, but it's the one that we're going to use so we can give you some pretty clear feedback and help you progress. The first section is going to be define the problem. This is probably the most basic, where you are just saying, hey, this is the thing that I'm trying to solve. I need to create a catapult that launches to a precise distance. I need to make I don't know, a device that can separate marbles into three different bins. So within that problem definition, there are two ideas, criteria and constraints. So a criteria is kind of your success factor. What are those things that need to happen in order to fulfill the problem? So your client may give you that. You may get it from a design brief, but these are things that have to happen. Like it needs to get with your catapult needs to be within 2 inches every single shot. I don't know. That is like what you need to be successful to show that criteria. Constraints are kind of on the opposite side, where these are restricting elements. So it could be, hey, for your catapult, you're only allowed to use certain material. You're only allowed a week to create this thing. You can only build it in a 2 inch by 2 inch space, right? These are things that restrict the criteria in order to actually solve that problem. Generating concepts is a nice way to get a whole bunch of ideas out so you can progress forward with the design process. Your big idea is to create as many ideas as you can possibly make so you can start to whittle that stuff down. So you may have ideas that are really stupid that may not totally work. That is actually a good thing because it allows you to work outside the box instead of just going with your first idea and bouncing from there. And there's four different ways that we can generate concepts. The first one, the most common one, is called free-form brainstorming, right? This is where you do brain vomit on a piece of paper. You sketch a bunch of stuff out. You say a bunch of stuff really quickly. You do post-it notes, getting those ideas out as fast as you possibly can. In our marble sorter project, this is what one individual did. They just did a whole bunch of sketches of different portions of their mechanism and how they might go together, right? It's not super refined drawings, but it's good enough to see exactly what they're thinking in their head. The second one is forced association. This probably won't apply to us a whole heck of a lot, but this is where you take two things that may not have to do with your project, smushing them together, and trying to get another idea out of it. So combining a wine press and a coin stamp will give you essentially a printing press from way back in the day. Scamper is really, really nice, especially if you're stuck with brainstorming and your ideas might be a little bit bland. Scamper is just an acronym that represents substitute, combine, adapt, magnify, blah, 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 where you can take an idea and tweak a few things in order to improve upon them. So substitute, you can replace certain components. Combine, maybe you smush a couple of ideas together. Adapt is, can you take an existing idea and tweak that? Magnify is, how can you exaggerate something? Maybe instead of a little index card, you use a gigantic index card. I don't know. Modify is, can you take something that you've already created and add features to those little portions? Put it to another use. Can you take something that is not meant for your project and actually make that apply to your work? Eliminate, is there a lot of waste? Can you trim down on stuff? Can you get rid of materials? Rearrange is if you modify the order or move stuff around, and reverse is, what if you just flip that whole thing on its head and thought about that in reverse. Scamper method is really, really nice if you do research online, and this individual said, hey, this is a cool idea I found on the internet. They gave them credit, right? HSE high school students, and they said, sweet, this is an idea I can work off of. And they spitballed and they modified based on this. They did not put this forward as their generated concepts. They tweaked it and changed it to fit what they were doing. And that's perfectly fine as long as you're giving credit where credit's due. I think it's a really good idea to do some of the projects that we have. Mind mapping, similar to our second one, probably is not going to help us out a whole heck of a lot, because this really corresponds to things that are monstrous problems where we need to break it down into multiple issues and solve those individually. So really, you're probably looking more at brainstorming and the Scamper method for the purposes of our class. Number 3, developing a solution. This is when you have all these concept generations and you need to figure out what is your next step. I'm going to skip forward here. And a decision matrix is a really good way to show that. So we are essentially taking ideas that you've already brainstormed and you are comparing them across different criteria that you've developed. So this individual, their criteria was they need low cost, they don't want it to be complex, and they want a low development time. So they just kind of rank these from 4 to 1, right? Not super scientific, but it may give you an idea that, hey, idea 3 I thought kind of sucked. Maybe this is the one that we pursue. Previously, this is one that was created for the Trust Project. So they valued simplicity, strength, and weight for their criteria. So they compared their concept generation to those ideas, which is a really, really good way to do that. You can also just do a written rationale if you want to do this in paragraph form. And that's perfectly fine. You need to be really, 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 really detailed to show that understanding. Usually a decision matrix is the way that people tend to go. Constructing and testing a prototype. So now you are ready to push forward with actually creating this thing and how to test it and show that it actually works. Excuse me. And this can come in a couple ways. Maybe you actually build the thing. So you grab some parts you constructed to see if it works based on your brainstorms. Maybe this is using a CAD software as a prototype, or you 3D printed to see if it actually works. But you need to be able to test it somehow. Right? You need to be able to get data so later you can figure out if it's worthwhile or not. So these individuals measured the mass of their truss, how much force it took to actually break that thing. So that gave them an idea that, hey, that second one they did is way, way, way better, and they're on the right track in terms of their process. And why we like that data is so we can evaluate these solutions. How do I know that this is meeting the problem statement that I created earlier? So what these individuals did was they calculated their efficiency. So there may just be calculations you can do based on that data to show whether or not it works. So they said, hey, we started with a 10.48 efficiency and we bumped it up to a 38.34, which is pretty stinking good. We can also use different graphs, right? We can use box plots. We can use histograms. We can use scatter plots. So you need to decide which of these methods is going to be the best way to convey the information that you have. And sometimes we can't get numerical data, but we can get customer feedback. So we can show them your CAD design and say, hey, what do you think about this? What can we change? What can we modify? Right? So it all depends on what type of a problem it is that will tell you how you need to evaluate that solution. And this is usually where you need to go back and change some things, right? You get feedback or data about something, you need to change it and you need to retest. Get feedback, change it, retest over and over and over until you're there. And last but not least is present the solution. So you have this final product, you've tested it, you've evaluated it, now you're ready to show that stuff off. For our purposes, we like to do the online portfolios, your digital engineering notebooks. It could be a presentation that you have with your group as well. Just how are you conveying the information that you have? So that was a quick and dirty version of the engineering design process. Keep in mind that there's not necessarily a wrong or right choice. However, you need to deeply think about which of these methods, between brainstorming or evaluating solution, which of these methods is going to give you the outcome that you are looking for. And whenever you select something, you need to provide a rationale to me.